All right, what we're going to do today is look through some application questions involving circular functions. The first one was the very first question of the Year 12 exam over a decade ago now. And what we've got is sine. So the standard period is 2 pi. And what we need to do is calculate the period by looking at the value of the coefficient of x here. This represents the dilation factor. So a good way to get the new period of this function is to divide by this value here, which is pi on 5. 2 pi divided by pi on 5 is the same as 2 pi times 5 over pi. It's 10. So the period is 10. Okay, what we've got is clearly a tan graph. And we can see here that the period occurs every pi on 2. The standard period of tan is pi, so this one here is half of that period, which means we need to dilate it by a factor of a half from y. And these are the only two possible ones that are a dilation factor half from the y-axis, determined by this 2 here. Now the other way you could do it is a little bit more mechanically. You can say that the standard period of tan is pi. We're going to divide that by a particular value to make the new period. And then all we do is we solve for this n value, which you can see when you solve for it is going to be n equals 2. So that's our n value, 2. And what we can see here is that the standard tan has, or goes through the origin at 0, 0. This one goes through the origin, well not the origin, but we can see that that point there has been moved pi on 4 to the right. So this one would represent pi on 4 to the right. So our answer is C. Okay, what's this one? The temperature T degrees inside a building T hours after midnight is given by this function here. The average temperature inside the building between 2 a.m. and 2 p.m. is... so probably the best bet is to just do a quick and dirty sketch of this to see what happens. So the period is, well, we've got a cosine function, and the period is determined by dividing 2 pi by this value here, pi on 12, which is going to be 24. So we're getting the period of 24. Now we can see also that this function has moved 2 units to the right, and we're looking for the average temperature between 2 a.m. and 2 p.m. and the starting point is after midnight. Okay, so let's get an idea of what this looks like. So we've got a vertical translation 22 units up, amplitude of 10, so it's going to top out at 32, bottom out at 12, not to scale. Then what's going to happen is this cosine function, because they're that negative, would usually start low and then it's going to move high, but that's going to happen 2 units later. So this represents 2 a.m. So it's going to start low, okay, and then what we'll do is just work out the scale. So it's going to be 24. So the action is going to be 24 divided by 4 equals 6. The action happens every 6 units. So it's going to be 8. Then it's going to be 14, which is 2 p.m. So what's going to happen is it's going to go up and up. It's going to go look something like that. So we can see that that's half the cycle of this cosine function. So it means that the average temperature would be the middle of these two sides of this trig function here. So the average temperature is going to be 22 degrees. Okay, if a function has the following two properties, okay, so what they're saying is we've got an angle theta, right? So if I go pi and I go theta back, that's the same as negative f of theta, all right? So it's going to produce the same value. So that's definitely possible for sine, right? So that's definitely possible. So no, it's not actually. f of, so this value here would produce this, and they're saying it's the same as putting a negative sign in front of this value here, which is not. We can see it's the same value, so that's not true. Now, f of negative theta is negative. Yep, that checks out. Excuse me. So cosine would be correct. Okay, so that would be a possibility. Now the reason, again, let's go why that's correct. So here's theta, pi take away theta. So it'd be here. We look down and that's the value there, which is negative, let's just go negative 0.5 maybe. Now that's the same as here, 0.5 with a negative sign in front of it. So that checks out. All right, let's see if this checks out here. So theta, pi take theta, so we're at the same point, is the same as this, which is negative. Okay, so we're going negative theta, so we're down here, which will produce positive, and then we negate the result. So I think it's cosine x. Okay, can't be tan because tan's negative there. Yeah, that's definitely cosine x. All right, now the function with the rule f of x equals that has the period. So tan has a default period of pi. We're dividing this by the n value, which is 2 pi in this case. So that's going to cancel out, giving us a half. The average rate of change. Well, I'm going to suggest that we don't do this question yet, and we save this for the unit on differential calculus. Okay, yeah, I don't think we should do the average rate of change yet. All right, so on to this application question. Trig the gardener is working in a temperature-controlled greenhouse, and during a 24-hour time interval, the temperature is given by this function here. Okay, state the maximum temperature in the greenhouse and the values of T for when this occurs. Okay, so let's do a quick sketch. So we can see that the period is 2 pi over pi on 8. So we can see the period is 16. That means the scale is 16 over 4, which is 4. So the action happens every 4 units of time. So 4 hours, 4, 8, 12, 16, 20, 24. Okay, now it's 25 up, goes to 27 as its max, 23 as its min. So it's standard cosine. So cosine starts high, it's going to go mid, low, mid, high, and then it's going to go low, low. So there is the temperature of the greenhouse. Okay, so state the maximum temperature in the greenhouse and the values of T for when this occurs. So we can see when it's going to be 27 degrees. So it's 2 marks. So we would say something like T of T equals 27, T equals 0, T equals this value here, which was 16. All right, how to do that on the CAS? So we're going to go define. Now, for trig functions, probably good to put a domain in. So with 0, it's a bit of a pain doing this, but okay. So now we're not going to get any general solutions. We'll get all finite solutions because it's only defined between 0 and 24. So what we would do is go solve f of x equals 27 for for x, 0, 16. So the times where it occurs is 0 and 16, or the values of t where it occurs. And we're going to say max temp is 27 degrees Celsius. Okay, the period of the function, we already calculated that. It's 16. 1 mark. Answer only. Find the smallest value of t for which t equals 26. So we can see that it's going to be here somewhere. And it says it's worth 2 marks. So what we're going to say is, we'll say t of t equals 26, where t is an element, and we'll tell it to hunt somewhere between, we can see, 0 and 4. I know that it's somewhere there. Okay, so let's go solve. F of x equals 26 for x. It's going to give us multiple solutions, and we're just going to take the smallest one because it's going to give us that one, and that one. So we're going to get 3 solutions. So we're going to say t equals 8 on 3. Okay, for how many hours during the 24-hour time interval is t greater than 26? Okay, so we can see that it's going to be here. So it's going to be this part here. Then it goes above again, which is this part here. Now, because of symmetry, the way this works, and I'll show you this properly in a sec. So this part here and this part here, what we're going to see, actually, I will graph this to show you. So we're going to go Control, Doc, and Graphs, and we'll graph f of x. Go and Window, 0 to 24, and we'll go 0 to 28. Okay, so there's our function. Right, I'm just going to put in a line, y equals 26. Now, what you should be able to notice is that this part here, the area of this part here, that it's above 26, is exactly the same as basically 2 lots of that same area. That would be this part here. So this doubled would be this area here. And this is always going to happen with trig functions because of the beautiful symmetry properties. Okay. Now, what we're going to do then is note that it's going to be this area here, 8 on 3. Okay, so 8 on 3 is when it's above, okay, or 2 2/3 of an hour, 2 2/3, yep. And then it's going to be the same amount of time. This would be another 8 on 3 and another 8 on 3. So it'd be 8 on 3 plus 8 on 3 plus 8 on 3, which is 16, 24 on 3. That's how many hours it's going to be above. Okay, is 24 on 3, or another way of thinking about it is 8, 16, 24 and 3. That's just 8 hours. So it's going to be 8 hours. The other thing you could do, just 3 lots of 8 on 3, is certainly 24 on 3. Okay, another one. This wasn't the end of the question, by the way. This Trig the Gardener question went on and ended up with something really... I remember the transformation question at the end was really nasty. All right, anyway, let's go with this one. The population of wombats in a particular location varies according to this rule. Find the period and amplitude of it. Okay, so the period is going to be 2 pi over pi on 3. That's going to be 6. The amplitude is this value here. So we're going to say amp is 400. Find the maximum and minimum populations of wombats in this location. All right, so what's going to happen is the maximum is going to be, this is the vertical translation, so that's going to send it up to 1,200, and then it's going to be plus or minus the amplitude, so 1,600 and 800. So max is 1600, min is 800. Find n of 10. All right, well, let me go back and define this now. Okay, now n of 10, so we're going to go f of 10, 1,000. Pretty easy mark that. Over the 12 months from there, find the fraction of time when the population of wombats at this location was less than n of 10. Okay, so less than 1,000. Okay, so for this, I think we need to have a better look at the graph. So I think the way we'll do this is so we're doing 12 months and the period is 6. Okay, so it's going to go through 2 full cycles. Let's just actually sketch this, I think is probably the best bet. Okay, so here's our graph. It's cosine. Cosine starts high and our period is 6. So the scale is going to be 6 on 4, 3 on 2. Okay, so 3 on 2, that's 1.5, 3, 5 on 2, and 6. So it's going to go up, down, down, up, up for 1 full cycle. Okay, so what we're going to do then is work out when the population of wombats was less than 1,000. So basically it's going to be between here and here, and then it's going to happen again, right? It's going to be the same again, except that's going to be exactly the same as this time here. So all we're going to do is find out what this time is here, and then just double it to get this answer here. Okay, so for the 2 marks, we're going to say 1,000 equals n of t, where t is an element, so we'll just tell it where to search, between 0 and 6. Okay, so let's go ahead and solve f of x equals 1,000 for x, with 0 less than x less than 6 as the restriction. Okay, so it's at 2 and 4. Remember, if you don't give a restriction, what Kaz will do is give you the general solution, which we don't want in this case. Okay, so it's between t equals 2 and 4. So find the fraction of time when the population was less than 10. So this would be 2 hours, or 2 months rather. Let's just check t is months. Yeah, t is number of months. Okay, so that's going to be 2 months, and then there's also going to be another 2 months in this section here. So we're going to say double 2 months is 4 months. Okay, now it wants it as the fraction of time, so it's 4 months out of a total of 12 months, which is 1/3 of a year. There's our fraction. So that's it. All right. So your job today is to do the applications questions from 14N. All right. And well, we've just done the VCAR questions. That's just what we completed there. So go for it. Do those applications. Use Kaz a lot. And I'll catch you later on in the week.